Okay, question 5. Given that angle B is congruent to angle E, angle C is congruent to angle F, B is at -3, 4, C is at 1, -3, E is at 4, -3, and point F is at 8, -10. Prove that triangle ABC is congruent to triangle DEF. Read the following proof for this problem carefully and then follow the instructions. So angle B is congruent to angle E, angle C is congruent to angle F. So notice in here that this has the two markings, the angle, and angle E is also marked as 2. That means that those two angles are congruent. That's how you represent it in math. Again, it says angle C is congruent to angle F, so notice that angle C and angle F both have 1 mark as well. And so those two are congruent, and that's how you indicate it in the pictures. And then it lists the points, and that is given. So they pretty much just recopied everything that was listed out right there. BC is equal to the square root of 65 and EF is equal to the square root of 65. How could they know that? Well, they had to use a distance formula. So segment BC is equal to segment EF. Blank 2 is going to be, well, let's see, what are all of our options? We have segment BC is congruent to segment EF. Nope. Side angle side congruence. No. Side side side. No. BC is congruent. No. Reflexive property. No. We're not making angles congruent. We were talking about side lengths. It is the transitive property of equality because they both equaled 65. So that's saying that we could just say that the first and the last equal the same thing. So that's their transitive property. So blank 3, definition of congruence. Okay, blank 3, if you're using definition of congruence, you're going to be looking for the congruent symbol since we were just talking about segment, the distance of BC and the distance of EF. I would look for the segment BC congruent to segment EF. And then triangle ABC is congruent to triangle DEF by what? What did they give us that we started with, and what did they include or find? So I'm going to work backwards. We found that this side length, BC, was congruent to side length EF. So there's the side that we have. Now, what was given was we had angle B is congruent to angle E, so we have angle. And we also have angle C to angle F. So it's actually angle side angle congruence. I remember this as a barbell because if I can draw a barbell at an angle, the side is representative of the bar and the other angle is representative of the other end. So it's like my barbell. That's how I check it. So it is angle side angle congruence for 4. Angle side angle congruence. And that's how I would go through this proof to answer it.